Now I'm going to step through the planets, starting with the inner or the terrestrial rocky planets, and I'm going to show you some photos, and I just don't think the photos or the slide I have for each planet does it justice, but you're going to want to kind of note some of the things that I note, and hopefully you'll find it interesting too. So starting with Mercury. Now Mercury to me reminds me, to me looks like the moon, like our moon. I know it's not, but it's got that kind of gray appearance, kind of for a similar reason that our moon has that appearance. Mercury is smaller than the Earth, and actually because it's so small, it's actually what we say geologically dead. It cooled off since the heat that it had as it formed. So it's kind of dead in the center. It's not, has no volcanic activity. Mercury rotates it rotates painfully slowly, like on its axis. Like a daytime in Mercury is like, I don't know, I think 200 and some days. So it's so slow that actually the side facing the sun, if this is the sun side, the sunlit part, and this is dark back here, okay, so this would be like night back here, and we'd have daytime right here. The fact that it rotates so slowly makes the sun side so crazy hot. And actually the night side is very cold, even though it's closest to the sun. I think that's interesting. Mercury has basically, we say, no atmosphere, very little atmosphere. Other things about Mercury is that, so relative to the Earth, Mercury and Venus are closer to the sun. After that, you get Mars, and then you get the gas giants, and they're farther from the sun than the Earth. So we have some kind of interesting things because of that with these two planets. These planets, the two planets that are inner relative to the Earth, Mercury and Venus, you will only see them actually close to the sun. So that's because they are, we'll only see them in our sky close to the sun. So that means as the sun is setting or as the sun is rising. As the sun is setting, we'll see them in the west near the sun, and as the sun is rising, we'll see them in the east near the sun. So we can't really see any features of Mercury, but if you see Mercury through a telescope, actually you can see Mercury naked eye. Mercury, again, near the sun, as the sun is setting or the sun is rising, it looks kind of like a red dot. And if you look through the telescope, you can tell it's a planet because it actually has at least a little bit of a disk instead of kind of a pinpoint of light. Oh, and then one thing, all of the planets we're talking about, none of the planets are putting out their own energy. They aren't glowing because they have some sort of fusion going on in their core. The only reason we see them is that light from the sun hits them, and that sunlight then comes back to us. So that's the only reason you see a planet. So after Mercury, we have Venus, and there aren't a lot of good pictures of Venus. This was taken actually, I believe, by the Hubble Space Telescope. Venus actually is a little bit of a mystery. It's kind of got that fuzzy sort of appearance you can see here. We can't see the surface. We've mapped the surface by using kind of this radar sort of thing. But so Venus actually will appear close to the sun always. Other things about Venus. Venus can be very bright. Oh my gosh. It's just crazy beautiful bright. Another thing about Venus, if you ever get a chance, it kind of goes through phases. You know, we have a crescent moon is the crescent phase of the moon. We actually have a crescent phase of Venus. I just think is a gorgeous. What else do we have? So I mentioned that we have mapped Venus, the surface of Venus, by using like a type of radar. Now this right here, actually, if I'm thinking of this right, this was the Soviet Union back in the 70s. We went to Mars, and they went to Venus. Something like that. Anyway, they did successfully land a spacecraft, and that spacecraft on the surface of Venus, and that spacecraft sent back a few images, and that's one of the images. Let's see, what else do we have about Venus? So we think that Venus actually might be a little bit geologically active, unlike Mercury. It's a little bit larger, it kind of retains its heat, and it's looking like there have been some kind of volcanic activity that may have gone on in the past and may kind of cycle back around. One of the things about Venus is it has what we call retrograde. Now, we talked about retrograde motion of the planets across the sky. This is actually retrograde rotation. So all of the planets rotate or spin on their axis that gives them day and night. Retrograde rotation means that it's backwards. Backwards. Kind of like retrograde motion of the planets across the nighttime sky. So in this case, backwards means actually clockwise. So backwards means clockwise. Everything else, if you're looking at the North Pole, well, I should say most planets, if you're looking at their North Pole, they spin counterclockwise, like the Earth and Mercury, Jupiter, Mars. But Venus goes clockwise. And actually, we think that's because it got whacked upside the head. No, really, it got whacked crazy severe early on in the formation of our planets, and it just flipped over. Isn't that cool? It literally flipped over. So that's an important thing about Venus. Now we get to Mars. We're gonna come back to Earth. We'll talk about Earth in a later in this unit, but Mars, then, the planet that's outer one step beyond Earth from the Sun, is a very busy planet indeed. So it's a cool target. It's been visited by NASA, the European Space Agency, and other space agencies. Now, Mars, we've got some amazing pictures. Actually, Mars is red. It not only looks red in the nighttime sky, but if you go from our photographs that have been sent back by rovers that are on the planet, it is red. It is so cool. It looks like the Earth, if you ask me. Down here is a photograph of Mars. Doesn't it kind of look like the Earth? And it's red due to actually iron, the element iron. It has reacted with oxygen in the past to form iron oxide. That actually is rust. So next time you look at rust, think of Mars. So here we see Mars. Mars has an atmosphere, and I didn't mention, goodness, Venus. Venus has a very thick atmosphere of carbon dioxide. That Venus has what we call a runaway greenhouse effect due to its atmosphere. Mars also has an atmosphere of carbon dioxide. It's not nearly as thick as Venus's. Another cool thing about Mars, you can see in this image, can kind of see that white thing right there. That actually looks like an ice cap, and it is an ice cap, but it's solid CO2, carbon dioxide solid. Mars does have seasons, so this would be probably winter in this hemisphere, and it's probably summer up here because there's no ice cap. All right. So here are some other photographs. This is so cool. These aren't just radar images like we get from Venus. These are photographs of the planet Mars. And right here we see kind of a rip across its middle. This actually is called Valles Marineris. I don't know if I'm pronouncing that right. I always think of kind of spaghetti sauce. But it's kind of a little bit like the Grand Canyon. And it's thought that actually split kind of formed out, so it was cooling. This is a humongous volcano. I think it's at about the size, did I read, of Missouri. Okay, it's a caldera, so it's not really an active volcano per se, but definitely looks like the cone was formed from earlier volcanic action. It's just humongous. It's called Olympus Mons. And there are other volcanoes on the surface of Mars. As far as I know, though, there are none actively spewing material. So I mentioned the ice caps. This is kind of interesting. As far as sometimes they call it weather on other planets. So just like we have kind of these dust devils that kind of come out of nowhere and kind of can race across the ground sometimes on Earth, Mars has little dust devils, little dust storms. With regard to a planet that can harbor liquid water, I think I said earlier in my lectures for part 2 that Earth was the only planet that was unique to be able to have water in its liquid state because it has the right temperature and pressures that allow water to do that. Actually, in the past, we know that Mars has also had liquid water, and there are many reasons why we know that. One of the reasons is we can see like dried up riverbeds of water that once flowed through Mars. I just think that is so cool. Am I thinking of this right? I'm thinking that there's been some photographs that have come in the last year or so from Mars, the surface of Mars, that we have actually seen some water movement. And I mentioned the carbon dioxide at the poles. What else we got? Yes. So with regard to moons, of course, Earth has one beautiful moon, and the other two inner planets, the Mercury and Venus, have no moons. Now Mars has a pair of moons, and they're right up here. The pair of moons are called Phobos and Deimos, meaning panic and fear. So they look kind of like potatoes, like the moons that only a planet could love. And actually these moons are, we think, captured instead of kind of formed along with the planet. That's why they look a little bit like potatoes. So one more thing I want to include in this section on terrestrial planets is the thing after Mars is actually a belt of what we call asteroids. Asteroids are just kind of rocky, chunky things, okay? So the asteroid belt contains lots of asteroids. Now they're usually generally small, about the size of a tennis ball, widely spread, and they do not pose harm to the Earth. Some asteroids have their own little satellite, their own little moon that orbits them. That's kind of cool. Asteroids, as you may have seen in the news, are actually targets if you're looking for to mining them and getting rich. Sometimes students wonder if we were to take all of the material in the asteroid belt that's after Mars and before Jupiter and to maybe stick it together, would it make a planet? And the answer is no, because it still would be smaller than our moon. Here we actually have one important asteroid. And the asteroids, just like the planets, oftentimes if they're big enough, they have kind of names, fancy names that kind of catch your attention. This is Cirrus. Meet Cirrus. Cirrus is actually, like Pluto, classified a dwarf planet. Cirrus has been visited by the spacecraft Dawn in the not too, has it been recent? Is it still there? I don't know. But so, and Dawn, the spacecraft, got some really cool images. Can you kind of see this illuminated part right there? That is so cool. So last thing is that, and I've never done it, that's why I guess when I prepared this slide I write the word supposedly, we should be able to actually see asteroids, large asteroids that are orbiting the sun through a telescope. Now remember, the reason we see planets is because light from the sun hits the planet and then that light comes to us. One of the directions it is in our direction, so we see the planet. The same thing is with asteroids. We basically have to catch the light from the sun and they will light up and we will see them that way.